Hello, everybody, and welcome to another edition of our Dome to Home series. My name is Jeremy. I'm a navigator, presenter, education guru at Fiske Planetarium, and with me we have my good friend Rémy. How's it going, Rémy?
I am going fantastic. How are you?
Doing swell. I'm so excited to join you guys. I haven't been on Dome to Home in a couple of weeks,
Same
and I've
here.
missed everybody.
Yeah.
We're doing our Earth series this week. And I mean, it's all month actually. It's Earth Month or Earth Day coming up here in a couple of weeks. And so today we're going to be talking about the top discoveries that we've made of our planet from space.
Yep, absolutely. Just a few logistics here. We also have our question master, Amanda, who is hanging out in the chat, and she is keeping an eye out for any questions or comments. So if you have a question at any point in the show, just toss them in the chat and we'll either answer them as we go or get to them at the end of the show when we have time specifically dedicated to questions. If you can't log into the chat, that's okay. We also have a question form. You can find the link to that either in the description or in the chat, either below me, to the side of me, however you're watching the video. Yeah, we definitely want to hear your questions because that makes the show and you get to learn what you want to learn.
Yeah, the participation is what we love because we do this for you guys.
For you, participation points. Yeah, so last week we looked into the like the sort of methods we use to look at our Earth. This week we're going to, as Jeremy said, look at some of our really great top discoveries made from space. And I'll admit it's not going to be a totally comprehensive list. We'd be here all day. So if you can think of any discoveries made from space that you really enjoyed and I don't mention them, let us know in the chat at the end and we'll go over them. But I've got a pretty good list here. So let's get to it. Yeah?
Sounds good to me.
Awesome. So let's jump right into it with what could be considered actually the very first Earth discovery from space, and it has to do with donuts.
Oh, right on. Are you kidding me? I love donuts. Hands down, like one of my favorite breakfasts. Not the most nutritious, 100%. But I can't go wrong with a good donut.
Can't go wrong with a good, no, not that kind of donut. Oh. We're going to talk about radiation donuts.
Okay. Well, I guess we could do that too.
Yeah. We can talk about the next Dome to Home donuts. No, so radiation donuts. So this discovery dates all the way back to 1958 to the first US satellite called Explorer 1. So Explorer 1 wasn't really large. It was maybe 30 pounds. It was less than 14 kilograms if you're, reasonable in the metric system. But it carried enough scientific instruments to get a sense of the, kind of space environment up there. So one of the instruments was a cosmic ray detector, which would, surprise, detect cosmic rays, which are really, really high energy particles zooming through space and hitting the Earth. It leaves a lot of charged particles in the upper atmosphere, bounce around and everything. We got a fun little picture here of cosmic rays that kind of make it look like an alien's attacking Earth, but those are cosmic rays. Mm-hmm. They come from, sources really, really far away, maybe like supernova, other stars, relativistic jets, etc. The sun as well. Yes, the sun's also involved. So they were first discovered in the 1910s with high altitude balloons. And scientists were like, hey, man, that's pretty cool. We want to learn more about these, little particles here. So Explorer 1 was a great opportunity to do that because it would be a pretty easy instrument to put on there, not cost too much, and actually get some science done. So what they discovered was that these particles were actually far more frequent at some elevations versus others where there were like none at all. So it turns out Earth's magnetic field traps these charged particles in belts of radiation, or kind of like donuts of radiation, it almost looks like. So there's Earth's magnetic field. You can kind of see around there.
Yeah, so these lines are showing kind of the path. You can kind of see their arrows. So Earth's magnetic field currently, leaves the geographic northern pole of our Earth, and it's like a giant bar magnet, kind of comes down back up through the southern hemisphere, through the southern pole. And what we're going to talk about here in a second is, can I use my mouse? Maybe not, but you'll see these two lobes here on the side, and kind of like these almost gaps. Rémy, you could tell us about those a little bit more.
I absolutely can. So these like belts of radiation, they were discovered by a scientist named James Van Allen. So it's called the Van Allen radiation belt. So there are these two, they call them belts around the Earth, but it kind of looks a little bit like Earth is in a couple of donuts. So maybe they should be called the Van Allen radiation donuts. That would be pretty exciting.
Yeah, and I'm pulling up the our donuts here. I had to make some changes behind the scenes real quick. One of the beauties of doing live shows is sometimes you have to fiddle with the donut pictures to get to the good pictures that we want to show, right like this.
Yeah, there we go. There's our donut cross section. Fun fact, the Earth is a donut hole.
Yeah, bet you didn't know that.
Bet you didn't know that. So sorry. So these are just two radiation belts surrounding the Earth, right? And they can actually kind of fluctuate based on how much radiation they're being hit with. And yeah, we just got two little donuts there, and that was like the first Earth discovery that we made through satellite.
And so this was really, really a big deal when they discovered these, because before, we sent these probes and kind of discovered this, we didn't know anything was there to begin with. And we, it had a little magnetometer that was going crazy, and it really opened up a lot of scientists' eyes to the idea, or, the reality that space is a lot more complicated than we actually previously thought.
Yeah. Actually, here's a fun fact about the radiation belts here. Sputnik 2 could have actually discovered these first, but the USSR couldn't pick up the transmitted data when the satellite was, in the right areas. And the countries that did pick up the data from the satellite, they weren't able to decode it because the USSR didn't share anything. They wouldn't share how to decode any of the information. So if they had shared, or if the satellite had been in the right spot for the USSR to really pick up on it, maybe we would be talking about the Vernov belt or the Laika belt. We named it after Laika, the dog who went up in Sputnik 2. What a cutie. Yeah. So, since these first satellites, like Explorer and Sputnik, we've launched thousands more. We saw some of those satellites. Ooh, my headphones. We saw some of those satellites last week. And it's not just satellites looking back on Earth. In fact, some of our most iconic and socially impactful photos of our planet came from cameras that weren't even in orbit around the Earth. And I want to take a look at a few of those.
Can do. We'll go ahead and put it there for a second. And sorry, all my windows just cascaded together. So I might need to restart our system here. Hold up.
That is A-okay.
All right, here we go. We're flying out here. So Rémy, where was this picture taken? Where do we need to go?
Yeah, so let's go ahead and head over to the moon. So the first human mission to the moon, the one that was like crewed, actually had people on it. Not on the moon, just to the moon, would be Apollo 8. So in 1968, Apollo 8 was sent out, orbited the moon, came back, and that was really neat. And it kind of paved the way for the rest of the Apollo program. On December 24th, 1968, an astronaut on that mission named William Anders he had the camera, he was over on the moon, they were coming, not on the moon, around the moon, coming over, and he saw the Earth coming up over the horizon, right? And obviously you got to snap a picture of that. That's incredible. And it's been dubbed one of the most influential environmental photographs. You'll recognize it when you see it. It's called Earthrise.
Yeah, as I kind of spoiled it, but sometimes there's some spoilers.
Sometimes you need some spoilers. It's okay.
That just happens. We'll try to give you the planetarium feel for it a little bit. This is maybe a little bit cooler than taking a picture. But so we'll see, as if we're orbiting above the moon here. Imagine we're in our little lunar module, and we're coming up just like the moonrise. There we go. We would see the Earth rising in the distance, and we would see this picture that was taken.
So that probably looks pretty familiar to you. That is just such a gorgeous picture. So yeah, since then, Earthrise has become one of the most well-known and recognized photos of our planet. But you might notice, catching the entirety of the Earth is a little difficult, considering you kind of have to be in just the right spot for the sun to illuminate everything in front of you. But on the way to the moon, Apollo 17 astronauts were actually perfectly placed for this.
Yeah, so I'm just kind of working on flying us back to where this location would be.
Yeah, no worries. Fun fact about that picture, actually. That was the first picture of the Earth taken by a human, not by a camera on a satellite. So that's pretty neat.
All right, so here we are kind of floating through space again. We have left the moon. We're flying back towards the Earth. And what is the iconic image that they were able to take, Rémy, once the astronauts were at a distance kind of like this?
Absolutely. So on the way out to the moon, they looked behind them and they happened to be just perfectly placed with the sun right behind them to take a picture of the entire Earth lit up. And it is now known as the blue marble image, which Jeremy spoiled a little bit as well. We had 2 spoilers in this video.
Whoops.
Yeah, it's such a good picture. How could you not have it though? Yeah, so I have heard actually that this is one of the most reproduced images in history, actually. It was taken in December of 1972, and it was the only non-composite image of a fully lit Earth. So this is all one picture, not a bunch of pictures taken together and kind of stitched. So composite image of a fully lit Earth for like decades. Until the launch of, it was called the Deep Space Climate Observatory. It's situated just perfectly to take images of the entire sunlit side of the Earth. Just, anytime, any day. But before that, you had to be at just the right spot at just the right time, and it just didn't align like it did in 1972. And actually, this alignment isn't quite the view the astronauts had. They actually were upside down compared to our usual map. We had Antarctica on the top rather than on the bottom, so they flipped it. But directions are made up. Jeremy and I had this discussion about directions are made up. It doesn't matter what up and down is when you're in space. It's just a matter of what we're used to looking at a map.
Mm-hmm. Yeah. Indeed.
Yeah. But iconic Earth photos wouldn't be complete without the pale blue dot taken by Voyager 1 in 1990 from beyond the orbit of Neptune. And we're going to head out there. And really quick, we had a question from Nathaniel, and this is a pretty good time to address that. So have we ever had a satellite go past the Oort cloud? So the Oort cloud is basically this big cloud of comets all around the sun, and they go out really, 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 really far. So Voyager 1 and Voyager 2 are the furthest satellites that we've sent, and they'll eventually pass through it, but not for a pretty long time. They're pretty far away, but not far enough to go past the Oort cloud. But yeah. So Voyager 1, there's its path.
Yeah, so we'll pause kind of right here. This, all the circular lines are obviously the orbits of our the planets in our solar system, and this yellow line here is the path of Voyager 1. You can see it stopped at a couple planets, did a few gravity assists, and got slingshotted out. And as maybe if we got about right here, what happened, Rémy? Did it just keep on going?
Well, it did keep on going, but as it was going, it took a picture. It turned around and took a picture of the Earth from 3.7 billion miles, about 6 billion kilometers away. And it actually almost didn't happen. There was really no plan to take a picture of Earth from so far away because there really isn't a lot of science to do with a picture from that far away. But famed astronomer Carl Sagan had the fantastic idea to snap a quick picture of the Earth while Voyager was out there. It actually took a lot of pushing. They were concerned about the sun maybe damaging sensitive equipment and just other issues. There was a lot of back and forth for years. And it actually took the head of NASA at the time intervening to make the picture happen. There it is.
Yeah, so it's kind of hard to really see what we're looking at here. And for anybody who hasn't seen, go ahead and type in the chat if this is your first time ever seeing this photo, because that would just be so cool. I would love to hear if that was the first time. What you're seeing here is the furthest image ever taken. That tiny little dot kind of slower on the right-ish side of your screen in that kind of beam of sunlight is the pale blue dot. That is our Earth, and it takes up just about 1 pixel, maybe 2 pixels on this image. And I wish I had a better way to kind of say the scale of this, but it is just puny. It gives us such a, you know, a realization of how small our own solar system is, and then how small our actual Earth is. And it looks like we have a couple of people who this is the first time, so that is so cool. Thanks for sharing.
That's neat.
Yeah, that's awesome to be able to share that moment with you.
I'm so glad we get to be the people to like show some people first time.
I know. That's so cool.
It's really, it's an incredible picture, because when you think about it from Earth, you know, we look in the sky and we see planets, and they're pretty tiny specks like that too. And you're like, you have to remember, oh man, that's a whole planet. That's huge. And it's kind of the opposite for this picture. You know, we think of our planet as huge. This is where we live. And we look back, it's just this little thing.
Mm-hmm. And then, so another kind of first, or not really a first, but in 2020, actually, one of the great things that came out of 2020 was an astronomical thing. Scientists revamped up this this picture a little bit, you know, to give it kind of a little bit more pop and try to keep the colors as true to the original data as it is. So you can see maybe that little dot a little bit better here. Maybe if I could give you guys a bigger view of it here as well. There we go. See another first. So many firsts. This is awesome.
Yeah. So those beams of light, by the way, those are just like the sun reflecting off of the spacecraft itself. But yeah, there it is, a little speck of dust over there. Really, really neat. But that's really far away, just a little far away. So let's go ahead and get close again. Not too close though, because there are some huge discoveries and leaps of understanding that have come from seeing the Earth as a whole system. So previously, we couldn't really get data on the planet, you know, all together, right? We had to stitch together individual information from really, really small areas, really local measurements of things. But now that we have satellites that can see more of the planet at the same time, and have even multiple satellites looking at more of the planet at the same time, we can piece together better images of the entire planet in motion. So our understanding of things like atmospheric processes and motions, and just everything on how the world works and moves, have really progressed thanks to visualizations like maybe this one. We've got a really cool one that we tracked down earlier today.
See if we get going. Oh, there we go.
Yes.
Is this the one you were thinking of, Rémy?
Yes, that is absolutely the one I was thinking of. So here you can see clouds over the planet there.
Yeah, let me try to zoom this out a little bit.
Yeah, just a little bit, and we can see a little bit more. So that shows really how our atmosphere moves around. So before then, you know, we could take some wind data, like someone over in Ohio is like, oh man, the wind's going 30 miles an hour today here in Cincinnati. And then someone in Florida is like, well, in Tallahassee, it's pretty slow. And you got to just talk to everybody, get these whole things. But you can get just entire beautiful maps and animations here. And actually, since we're talking about, you know, storms, Annabelle wanted to know how the storm on Jupiter got so big.
Oh, good question.
It is a good question. So you can see here on Earth the way that, can you find, I know that there was like a storm that's actually being made on Earth in this data, I think somewhere in the Atlantic.
Yeah, if you look right off the coast of, so this is kind of like a time lapse, and so you can see it kind of keeps restarting. And right off the coast of Florida, which is, maybe I can zoom in a little bit more. It might be tough for you guys to see. It's on that kind of the right side of your screen here. You'll see this big kind of storm start to form and move up the coast. And I don't remember if this might be Sandy, Hurricane Sandy.
I don't quite remember. But storms like that are made, I hear YouTube's being a little bit laggy. Sorry about that.
Oh no.
So that's unfortunate. Hopefully it catches up. But storms like this get made on Earth, you know, all the time. We have weather systems come together, make these storms, and they tend to go away when they kind of get over land or for other reasons. On Jupiter, Jupiter is huge. It is much, 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 much bigger than the Earth, right? So you can have a lot more motion happening in the atmosphere. These storms can actually come together. You can see, or if you remember when you saw in the data, you've got like clouds kind of coming together, so they would converge. And over time, you end up with this giant hurricane, just a huge hurricane. You can fit 3 Earths across this storm on Jupiter. That's the Great Red Spot. And there are other storms all throughout Jupiter. The Great Red Spot, though, has been going for at least like 400 years, ever since we've been looking at it from a telescope. So probably longer, and it's going to keep going for a little bit, though it is shrinking. But that's basically how it happens, the same way that we get storms here on Earth. Jupiter gets them, but they last really long time and can come together with other little storms. Okay. It was too powerful. We've asked a lot of it. Yeah, thank you. Yeah, so satellites here on Earth, have really provided us with the data we need to track things like that cloud motion and storms and things like that. Temperature data, sea surface height, seasonal changes. They've given us the capability to predict weather and predict the future of our planet too. We talked a bit about how this kind of works and what it looks like last week, so I won't go too in depth, but our knowledge of the Earth as a planet, a whole system, has really increased exponentially since we've been able to actually see it as a planet as a whole, right? That's kind of how we make those comparisons, like to Jupiter, Earth as a planet, Jupiter as a planet, that sort of thing. It's really exciting. But let's go ahead and talk a little bit about the human factor just for a moment, because satellite images can show us a lot about how humans shape the surface of the Earth as well. So using satellites, we can track things like urbanization and population growth. You can see here, this is Las Vegas. That was in the mid-1980s versus within the last couple of years here. So you can see that the city has gotten huge, and even the lake over to the side, Lake Mead, has gotten smaller because of the water needs the city. We can keep track of things like that. We can keep track of land use as well, who's using what land and for what purpose. It's really, really evident in things like deforestation, and things like deforestation, where you can see, oh yeah, here it is. This is cool. So you can see here that not only is it that the forests are, going away, you can see that it's being used for different things. It could be used for farming, for logging, or for cities. And that's something that you can track with data or satellites and space data. And just really get an understanding of how that all works. You can also see what our planet looks like at night. We've got a really cool image from the space station, right? This one's from the space station?
Yeah.
Well, not that one.
Sorry about that. I got my order all mixed up. So this one,
that's okay.
This is a video taken over Saudi Arabia from the ISS. You'll start seeing, I'm going to go back to full screen here so that you guys can see up close, but you'll see all these kind of lights starting to flickering and or start to flicker. And so those are actually, storms in the upper atmosphere or lightning strikes. And then you kind of start coming over some bigger cities here. Yeah, where you start seeing like, whoa, that's a very big city right there. Another kind of, outskirts, and they're all over the place. And then, yeah, you kind of see the sun start to rise on the other side. What I like to kind of think about is humans' impact on, astronomical viewing in particular. And so it's hard to kind of see when we look at something like that, because that's, over the course of 90 minutes. But I like thinking about like what that impact would look like over the course of 100 years, for instance. If we could take a time lapse over 100 years and look at what the city lights, how cities have been growing. And I know that there's some, some good ones out there.
Yeah, studying things like this, it can really help out things like ecology, sociology, even politics, all sorts of disciplines that you really might not expect. Discover new ways of looking at the world and understanding and tracking not just how the Earth works, but just how human behavior works. And in fact, even
Rémy, you there?
I'm here.
Oh,
I
yeah.
got muted.
Yeah, you just got muted there, but
When did I get muted?
I think it just cut out briefly.
It just cut out? Okay,
yeah,
cool.
I think we're good.
So archaeology. So archaeologists, they can use space data to find and map things like ancient roads and settlements and even buried artifacts. So space archaeology, as far as I can tell, it's kind of a bit of a niche field, but we can use, for example, radar to peer underneath the surface, like you can see here. So radar, what happens is it puts out a light pulse, and then it bounces back, and then it measures how long it took to come back to it, and then it can tell you just what the surface looks like, right? So when you have buried treasure, buried cities, buried buildings, I guess they're treasure to an archaeologist, they're treasure. You get like a different response time in your light. So it might be able to go through more of the ground, but then some places it'll hit a building or a structure, like you can see here. So on one side, you have is it the left, the right side? The right.
Should be the left side without the radar. The right side is the radar.
There's the satellite. Once again, I have to admit, I don't know my left and right well enough. So you have on the side far from me, the regular satellite data, and it looks, like farmland, just normal satellite. Then you have radar data, and you can see all those little dots there are little structures. So they have found like tens and thousands of structures like this, particularly Mayan ones in like Guatemala and such. Been really exciting to use satellites to do this. It's stuff that you wouldn't be able to get to because you'd have to very specifically find a spot to dig, and it's a pain. But we can also use just visual satellite map data to get a big picture view of an area. Look for patterns that might indicate roads and buildings where they might be or where they might have been, but we just haven't gotten to them on foot. Or to get a new view of a place we've only really seen from the surface, from the inside.
Or from movies.
Or from movies. What do we have here?
Yeah, so if anybody is an Indiana Jones fan, in the original movie, he was searching for the lost city of Tanis, I want to say. This is a real place. This is an actual city that a scientist, drawn a blank Parkic. What was her name, Rémy?
Sarah Parkic?
Sarah Parkic, yeah. She's done a lot of work on this. And she has used satellite imagery to take a picture of the city of Tanis. And she's used kind of radar to look below. And in this radar image that you'll see over here, she noticed something funny. She said, there's probably something down there. And she went down and looked. And I'm oversimplifying her work greatly here. But she was able to actually find, a city by using satellite data, which is very, very cool.
So even places where there might be something there, you can see even more and get a better understanding of what was there before. It's really exciting. And actually, even Cold War era spy satellites have been a huge resource for archaeologists. Just looking down and seeing those, and you can find cities and things like that. Really exciting. So using those techniques, we've uncovered tons of sites, lost cities, gathered more data. And they can really, satellites really tell us a lot about the past and how humans have left a mark on the planet. We can also see what's happening now, not just with humans, but how the Earth works now and what the future might hold. And next week, we're actually going to talk a bit more about what the future of our planet might look, and especially how we, as humans, have changed it and continue to change our planet. So be sure to come back for more in-depth look at that. But I want to be sure that we have time for questions. So let's go ahead and just open it up for anyone that has any burning questions, whether that be about, space discovery or Earth discoveries from space, anything that we talked about, space in general. You've got two fantastic experts. What did you say? You're a guru? We've got a guru over here.
Guru, yeah. Apparently, I'm not a tech wizard yet.
No.
But yeah, since we did hit all the way up to 3:30, we want to maybe stick on a couple minutes to answer some questions for you guys, because I know we ran into some issues, but
Yeah, it happens.
It happens.
We're live.
Live shows. But yeah, drop any of your questions in the chat. I think Amanda has also listed that link to the question form if you would prefer to drop your question on the form. When we're waiting for some stuff to come in here, what is your favorite discovery of the Earth? I told you I was going to ask you this, Rémy. I have to do it.
You told me you were going to ask me this, and I told you I was going to say the best Earth discovery from space, for me personally, is getting directions from place to place with GPS and satellites like that.
I'm right there
that's a
with
personal
you.
Discovery almost daily.
Yeah, I would be a hopeless wreck if I did not have GPS.
Yeah,
I would never get anywhere on time, ever.
I don't think I could find my own house.
I mean, and that's bad for an astronomer too, because ancient astronomers use the stars to navigate and get places, and I'm over here like, I need my iPhone to tell me where to go. It's just, I need to do more research, and I need to get more in touch with ancient astronomies, I think.
Well, I don't even know my right and left, so I think even if I knew where the stars were. Actually, we got a question submitted before the show, and it's, how did space get so big? Which is a big question, really big question.
Pun intended.
Yeah. Get it? Pun intended. So space did not start out very big, actually. Everything here in the universe, everything that you can see, that we can measure, all the matter and energy, was crammed into a very infinitesimally small point, just into practically nothing, right? And then it exploded outward and it was called the Big Bang, where all of the matter and energy just exploded outward. And from then, I'm going to really oversimplify it. It's been expanding since then. It's just been getting bigger and bigger and bigger, and expanding so fast that we just have this huge universe today. And that's how we end up with so much space in space, and how space got so big.
That is a very big question. Very great question, though.
Fantastic question.
Try to bring up a little bit of a picture of the history of the universe, just to give you a little bit of a sense. And of course, I just stretched it a very, very bad way.
Fisheye.
Never mind. We're gonna scratch that one. Rémy hit the nail on the head with everything you need to know.
Yeah, absolutely. We had a submitted question. Why is Earth's atmosphere blue? So there's a lot of blue happening with Earth, right? So we've got blue sky, blue water, all that stuff. Our sky is blue because of the way light scatters and the type of molecules we have in our atmosphere. So we have a lot of nitrogen in our atmosphere, and just the way things scatter in nitrogen, in a nitrogen atmosphere, it makes the sky look really blue. And actually Pluto has a blue atmosphere as well, because there's a lot of nitrogen. So if you were on Pluto, you would also see a blue sky. You would also be really cold. Would be great.
Yeah, this is not a picture from Pluto. This is a picture from Venus, which you can see kind of the difference in atmosphere. Definitely not blue, and that's also because of how thick it is, and as Rémy said, the composition of that atmosphere.
So we've got a lot of sulfur here, so it's really yellow.
Let's see, we could show you a picture from Mars too. You can kind of see the atmosphere in the background there. This is Curiosity rover, who snapped this photo for us a couple years ago. You can see how it's kind of that, I don't know, what color is that? Brown, pinkish haze? Gray? It's kind of a gray. What do you think, Rémy?
Yeah, it's kind of like a pinkish gray, pinkish gray. What color do you all think it is? Go ahead and let us know in the chat what you think. But really quick, I want to make sure. So sunrise and sunset, you see kind of a little bit more reddish and orangish. That's not because for some reason the nitrogen all went away. There's just a longer area, like a longer path that the light has to go through. So more and more and more light gets scattered. So by the time it gets to us, it's just a lot redder. It's not that there's a lot of like other stuff in the way.
Yeah, it's a good point.
But that is why you see redder or oranger sunsets and sunrises when you have things like wildfires or pollution.
Fun fact, sunsets on Mars have a slightly bluish tint, correct?
I think so. I feel like I heard that.
Yeah, I would love to live on a planet with like just really wild colored sunsets. That'd be fun.
That'd be nuts. People from other planets come here and they're just like, man, blue sky. Imagine that.
Yeah. It looks like Denise in the chat says, it seems like discoveries are happening more often. When did we get to the point where we could gather so much information and share it freely? That is a wonderful question. Rémy, you want to take that one?
Big question. Yeah, so that's an interesting question, especially with the share it freely caveat there. So generally, when it comes to doing science and making discoveries, we try to be pretty open about it. There are some discoveries that they really were keeping under wraps, especially during like the Cold War era, things like that. It kind of made it really difficult to be sharing all the information freely. Like the Cold War satellite data, for example, a lot of that is actually fairly new within the last 20 years because they weren't releasing it. And that's why the archaeology with those are a lot more recent. And that's kind of, we've come to a point where we're sharing scientific data a lot more freely, though, I feel like. I don't know. What do you think, Jeremy?
Yeah, I think so. There's not much I would add there. You know, to gather so much more information is just, we're gathering more and more and more information almost exponentially every single day. I mean, the amount of information that we have on some space missions, most space missions, we haven't even had time to really like sift through.
Some of the discoveries are like data from 2016 said, and it'll be something published this year, you know?
Yeah, and so, I mean, it's really just a matter of, I think everybody should share their data, but not if you're trying to, you know, produce your own scientific results. But science is a very
you also need to like get
collaborative
people
community, so
confirm things and stuff.
Yeah, exactly.
We get more and more discoveries, more and more data as we, you know, take more and more measurements and send more and more instruments out there. And then what has been the latest discovery? Great question. I'm trying to think of some really recent discoveries. Jeremy, can you think of one off the top of your head? I know they just come out a ton, but
planetary, stellar, I mean, Earth, I don't know. There's so many options. I would say the one that I've kind of been focused on.
Are we both muted?
Let's see.
There's a message in the chat that says you're both muted.
Oh, I sure hope we're not both muted.
Amanda, are we muted?
No, I don't think so.
We're not muted. Okay. Just make sure that your video is not muted. Sorry, I just wanted to make sure before we like talk for 2 minutes and it's just silence.
Yeah. I would say that I don't know, I guess the most recent discovery of space, but I would say that it will the most recent life discovery or possibility of life was probably phosphine in the Venus atmosphere. There's a little bit of debate on what's going on with that. There's some other teams that are
a lot of debate on that one.
Double check the data and make sure that, you know, what they saw is actually what they saw.
There's a little bit of drama with that one too.
I think the one that I'm most excited for right now is definitely Perseverance, the rover that just landed on Mars. I think there's a lot of promise with what Perseverance can find. And it's roving around, and Rémy loves Perseverance. She loves a helicopter in particular.
I love Ingenuity so much. That helicopter means the world to me. We have had a few issues with it though, apparently. So they've been kind of putting off the flight date, and I'm really hoping that this thing flies. Ever since I heard about it last year, I've just been obsessed with this little helicopter. So we had in the response form, someone was asking about a satellite crossing the Oort cloud and what do we need to cross the Oort cloud. from Nathaniel. Yeah. So we haven't had a satellite cross the Oort cloud just yet. Like we were saying before with Voyagers 1 and 2, they're getting pretty far, but they're not into it, crossed it, passed it, or anything like that. To get to the Oort cloud, what we need is time. Really, give it enough time, and Voyager 1 and 2 will get there. Anything that we sent out, New Horizons, Pioneer, all that stuff, they're on the way. We just have to give them time, a lot of time. It took, let's see, what, 50 years, 40 years or something for Voyager to get where it is now?
Yep. It's been traveling out there for a
40 years.
long time, and it'll
50?
keep on going for a long
time.
Speaking of time,
Yes.
unfortunately, I think we have gotten to the end of our time today. As always, guys, we love having you come back. Please like, share, subscribe, and spread this around because we do it for you. And if you have any other questions, reach out to us. We're hopefully going to be getting back in Fiske, maybe soon. But you can check out our website.
Hopefully, keep an eye out.
Yeah, keep an eye out. We got lots of links down below. Lots of information.
Instagram, Facebook, Twitter.
Provide us some feedback and join in next week. We'll be talking about some natural disasters and how we kind of view the Earth and how we use satellites and observations and discoveries to plan for the future.
Thank you all so much for joining us. Come back next week. If you enjoyed this video, definitely go ahead and like it, leave a comment, or send it to a friend. If you have any other questions that we didn't get to, leave a comment, send it in our submission form, or come back next week. And subscribe to our channel, turn on notifications for more videos like these. And in the meantime, you can also take a look at some of our older Dome to Home videos or listen to our podcast, A View from Earth. From everyone here at Fiske, thanks for watching with us, and we will see you next week.
Bye, everybody. Thank you.
Bye.